Welcome to this comprehensive tutorial on creating an optimized bullet hell shooting system in Unity. Bullet hell games are renowned for their visually stunning, screen-filling projectile patterns, which often present significant performance challenges for developers. These games, characterized by their intense and intricate bullet designs, push game engines to their limits, demanding efficient resource management to maintain smooth gameplay. The core issue arises from the constant instantiation and destruction of thousands of bullet objects, leading to substantial CPU overhead and noticeable lag, especially during intense gameplay moments. This frequent creation and deletion of game objects can severely impact your game's frame rate and overall responsiveness, causing frustrating stuttering and a degraded player experience. Each time a new bullet is created, memory is allocated, and when it's destroyed, memory is deallocated, a process that becomes incredibly taxing when repeated hundreds or thousands of times per second. In this video, we'll tackle this critical performance issue head-on by implementing a powerful and efficient design pattern known as object pooling. This technique is fundamental for optimizing games with many rapidly appearing and disappearing elements, providing a robust solution to the performance bottlenecks commonly found in bullet hell and similar genres. Object pooling allows us to manage game objects much more effectively than traditional instantiation and destruction methods. Object pooling is essentially like having a dedicated library or a ready-to-use inventory for your game objects. Instead of generating a brand new bullet instance every single time our player fires, which is a costly operation, we simply borrow an existing one from this pre-populated pool. This pre-allocation of objects significantly reduces the runtime overhead, as the system doesn't need to constantly create new objects from scratch. Once that bullet has served its purpose, perhaps by going off-screen or hitting an enemy, we don't destroy it. Instead, we efficiently return it to the pool, making it available for reuse later. This clever approach completely bypasses the performance-intensive instantiate and destroy calls, which are major culprits for performance drops in games with many temporary objects. By recycling objects, we avoid the garbage collection spikes that often accompany frequent object destruction. By doing so, we significantly reduce the computational load on the CPU, leading to much smoother gameplay, even with hundreds or thousands of projectiles on screen simultaneously. This is a cornerstone technique for creating high-performance games, ensuring a fluid and enjoyable experience for players, regardless of the intensity of the on-screen action. The benefits extend beyond just bullets, applying to any temporary game object like particles, enemies, or power-ups. Let's begin by setting up our Unity project. First, create a new 3D project in the Unity editor. This will provide us with a clean slate to build our shooting system, ensuring no pre-existing assets or configurations interfere with our tutorial. We'll start with a fresh environment to clearly demonstrate each step of the object pooling implementation. Next, we'll need a simple player object that will serve as our shooter. For demonstration purposes, a basic cube or sphere will suffice. This object will be responsible for initiating the bullet firing, acting as our primary interactive element in the scene. We'll keep it simple to focus on the core mechanics of the shooting system. Finally, we'll create a bullet prefab. This prefab will be the actual projectile that we intend to pool. Ensure it has a rigid body component for physics interactions, allowing it to move and collide realistically within our game world. This prefab will be the template from which all our pooled bullets are generated. Now, let's dive into Visual Studio to create our objectpooler.cs script. This script will be the central manager for our object pooling system, orchestrating the creation, retrieval, and return of all pooled game objects. It's the brain behind our efficient bullet management. We'll implement the singleton pattern to ensure that only one instance of our object pooler exists throughout the game. This makes it effortlessly accessible from any other script without requiring a direct reference, simplifying our code and preventing potential issues with multiple pool managers. The awake method is the perfect place to initialize this singleton instance. To manage different types of pooled objects, we'll define a list of pools. This allows for flexibility, enabling us to pool various game elements like enemies or visual effects in the future, not just bullets. Each entry in this list will specify the type of object, its prefab, and the initial size of its pool, making our system highly scalable and adaptable. In the awake method, we'll initialize each pool and pre-instantiate the specified number of objects. This crucial step happens when the scene loads, ensuring all objects are ready before gameplay begins, eliminating any potential hitches during the initial moments of intense action. We'll populate a queue game object for each pool, making object retrieval very efficient. The getObjectFromPool method is responsible for retrieving an inactive object from the designated pool. It finds an available object, activates it, and then returns it for immediate use. If the pool is empty, it can optionally create a new object, though for optimal performance, we aim to pre-instantiate enough objects to avoid this during gameplay. This method is the primary way other scripts will interact with our object pool. Conversely, the returnObjectToPool method handles putting an object back into its respective pool. It deactivates the object and enqueues it, making it available for subsequent reuse. This process is vital for recycling objects and preventing unnecessary destruction, which is the core principle of object pooling. It ensures that objects are always ready for their next deployment. Next, we'll create the playershooter.cs script. This script will contain the logic for our player to fire bullets, utilizing our newly created object pool. It will be responsible for requesting bullets from the pool and setting their initial properties before launching them into the game world. Within this script, we'll obtain a bullet from the object pool using ObjectPooler, instance.getObjectFromPool. We then set its initial position and velocity before effectively firing it into the game world. This approach replaces the traditional instantiate call, ensuring that we are always working with pre-allocated and recycled objects, which is key to performance. Crucially, instead of calling destroy when the bullet is no longer needed, such as when it goes off-screen or collides, we will call ObjectPooler, instance.returnObjectToPool. This is the fundamental key to our optimization strategy, as it avoids the performance overhead associated with memory deallocation and garbage collection. This simple change has a profound impact on game performance. This direct return to the pool prevents the costly overhead associated with creating and destroying game objects, ensuring a smooth and efficient bullet hell experience. By recycling objects, we maintain a consistent memory footprint and avoid performance spikes, even during the most chaotic moments of gameplay. This is where the true power of object pooling shines. Now, let's connect everything within the Unity editor. First, attach our ObjectPooler script to an empty game object, which we'll name Pool Manager. This game object will serve as the central hub for our object pooling system, making it easy to locate and manage within our scene hierarchy. Next, attach our player-shooter script to our player object. This links the shooting logic to our player character, allowing it to interact with the object pool and fire bullets. This step integrates the player's actions with our optimized bullet management system. Finally, we'll configure the object pooler in the inspector. We'll set the bullet prefab and specify an initial pool size, for example, 100 bullet objects, to be pre-instantiated at the start. This ensures that a sufficient number of bullets are ready and waiting in the pool before gameplay even begins, preventing any initial lag. And there you have it. As you can observe, our CPU usage remains remarkably stable, even when hundreds of bullets are actively present on screen, demonstrating the power of object pooling. The Unity profiler clearly shows a flat line for CPU activity, a stark contrast to the spikes you would see with traditional instantiation and destruction methods. This visual confirmation highlights the success of our optimization. By effectively utilizing object pooling, you can now confidently create complex and visually impressive bullet hell patterns without compromising your game's performance or sacrificing frame rate. This technique empowers you to design more ambitious and engaging gameplay experiences, knowing that your game will run smoothly even under extreme conditions. It's a vital skill for any game developer working with many dynamic objects. Thank you for watching this tutorial. We hope this guide helps you build optimized and engaging bullet hell experiences in Unity. Be sure to like and subscribe for more Unity development tips and tricks, and feel free to leave comments with any questions or suggestions for future topics. Your support helps us create more valuable content for the game development community.